Good afternoon to one and all present here. I feel privileged to welcome you all on behalf of EC department for the TechUp3 sponsored two days online workshop on IoT and machine learning algorithms towards smart ecosystem during 25th March 2021 and 26th March 2021. Thank you for joining us for this workshop, and I wish to extend a warm welcome to our resource person, Dr. Srinivasalu Reddy, NIT Trichy. Welcome you, sir. It's my privilege and honor to introduce the resource person. Dr. Yu Srinivasalu Reddy received his PhD in 2013, Department of Computer Applications, National Institute of Technology, Tiruchirappalli, Tamil Nadu, India. He started his academic career as a lecturer in the Department of Computer Science, Bishop Heber College Autonomous, Tiruchirappalli from 2003 to 2006. He started his research career as a full-time research scholar in the Department of Computer Applications, NIT Trichy, from 2006. He joined NIT Tiruchirappalli as an assistant professor in 2008. His research interests lie in applying various artificial intelligence approaches to extract useful patterns from different facets of societal challenges of high demand with economic benefit. The main aim of his work is to develop machine learning and deep learning models for various domains like agriculture, bioinformatics, banking, telecom, and healthcare. With this motivation, he has established Machine Learning and Data Analytics Lab in 2015, and he is a core team member of the Center of Excellence in Artificial Intelligence established in 2020. His research team of 12 doctoral students, 10 post-graduation students are highly motivated and enthusiastic in working out to achieve better outcomes. For his credit, he has produced 3 doctoral till date and 10 post-graduation students annually. He has published more than 48 journal articles and conferences and 2 book chapters. He received Best Researcher Award in 2018 and Best Performer Award in 2019 from NIT Tiruchirappalli, 2 Best Paper Awards in international conferences. He received a full educational scholarship from the Residential Care Program from Kindernotfile KNH Germany from Schooling of Masters. He received various research grants worth of rupees 127 lakhs from various funding agencies such as ISRO, Naval Research Board, Defense Research and Organization, Department of Science and Technology DST, and Department of Electronics and Information Technology DAIT. He conducted many national workshops, conferences, and training programs. Dr. Reddy has delivered more than 40 invited talks in national and international conferences, workshops, and faculty development programs. He is a life member of the Computer Society of India, an annual member of ACM, IEEE, and Analytical Society of India. Now I request our chief guest, Dr. Yu Srinivasalu Reddy, to deliver his speech.
Good afternoon. Good afternoon to one and all.
Good afternoon, sir.
Thank you, madam. Thank you, madam, for a nice introduction. I take this opportunity to thank organizers from the Department of ECE CIT, Coimbatore, for inviting me to give a talk on introduction to IoT and its applications and future perspectives or trends and challenges. So with this motive, and we'll go to the topic. If you have any doubts, you can type in a chat box or you can share with me. And at the end, we'll clarify the doubts. Or in between also you want, I will clarify that. Madam, my slides visible, madam?
No, sir. Yes, sir.
No, madam? Yes.
Yes, sir.
So, good. Yeah. Shall I go ahead, madam? Yeah. So
yes,
now
sir.
that IoT, everyone is talking about IoT, Internet of Things, Internet of Everything, Internet of IIoT, Industrial IoT, and AIoT, Artificial Intelligence and IoT. So nowadays, everyone is talking about what is the IoT and Artificial Intelligence. Now, it has a lot of application and it come into the reality. Now, every day we are using IoT services even every minute also we are using IoT services. How these IoT devices are getting into connected and processing and analyzing and helping the human society, not only the humans and also industrial IoTs, either in medical field, in agriculture field, in any field you take it. Now in future, everything is under control of sensors only. Everything is a sensing. So how this technology has come up? How this? First, I will give the introduction about IoT, and I will take one or two applications in medical and transportation, then a smart home. After that, I will discuss in detail with the IoT applications in agriculture. Then what are all the challenges currently we are facing in IoT devices or in IoT technologies with respect to the artificial intelligence, machine learning, deep learning. Then what are all the scenarios in Indian government? How that the Indian government is promoting these IoT technologies and AI initiatives. So then what are the future challenges? That's what my talk consists of. So this is the basic thing. So everyone knows we are mimicking the 5 senses. So these 5 senses, based on this only artificial intelligence has been developed. So by technology, whatever that our vision technology, based on this vision, how we are able to see, how we are able to recognize, how we are able to detect, how we are able to classify, how we are able to picturize some object or anything what you are seeing and captioning that thing, right? Like that, and a computer vision is a new field. Now everyone is looking into the computer vision, right? So everywhere now after deep learning has come up, right? So artificial intelligence is the future of computer vision, right? So many vision technologies now they are developing. For example, GPS, Google has now. Now they are making that GPS as a VPS, vision positioning system, visual things, right? Now instead of textual, we are going for visual things. How these visuals are able to see, how they are being connected, our surveillance cameras are all connected, no? How this information has been deployed and making some useful inference from it. So there, see, if you see the surveillance camera, now people are looking at every time that has been recording. Now the people, how much data has been generated and we have to store and process it. So sometimes without any action, any activity that has been recording. So now people want to avoid that one and making when an event happen, the presence happen, something is happening. That time only the camera is able to, surveillance camera is able to detect. So now in the Sony company, now they developed one very good intelligent vision sensor. They're now sending the information to the cloud and processing at all. Everything has been done within the edge itself. That presence sensor that I will take you into later. Like that, no, here, touch, that electronic, e-nose, e-tongue, all these are the basically we have by birth, we have all these 5 senses. Now people are want to transform this into the computer science. Right, see. So what is a human analogy with related to IoT? All are devices only. Now, with respect to human body, our human body parts are called what? Human body parts. It's a here 3 emerging available in the current trend. One is IoT devices. Second one is an artificial intelligence. Third one is a blockchain technology. I will relate these 3 technologies into our human analogy. So in the human body parts, so we have legs, eyes, and hands, everything. It will sense and send the signal to our human brain, right? Now these human body parts are nothing but an IoT devices. All our human body, if something happened to our leg or finger, immediately it will sense and give the signal to our brain. Then brain will take action. Brain will decide what to do, what not to do, right? So all our body parts now as called as an IoT devices. So easily, see, everything, nature is the rich resource to learn many things. Now, biologically, God has given our human body. How our human body are connected to exchange the information between them. Right? Same concept now IoT is. Right? Second one is who is controlling all these things? Human brain. So what is the technology now here is artificial intelligence. Their decision making, whether whatever the problem is happening, whether I have to go to the hospital or I have to first aid itself is enough, or if something our body part will indicate you after seeing something, can I take or buy or not to buy, all these decisions, all this classification, I want to buy that product, then what does the amount is left out. So whether already this similar kind of product is available in my home or not, that and all you are categorizing, grouping or classifying, or all these things your human brain is doing. That where the intelligence, artificial intelligence is coming. Now, so in every human brain, we have a memory. So that's why that memory cannot be altered. I cannot make any alteration in your memory. See, all these IoT device parts, are connected, right? Then it is exchange of information between these body parts to human brain. Then this information is stored in the memory. I cannot alter your memory. See, your memory cannot be altered by somebody else. So now you are secured. That's why even you store a wealth, somebody can come and steal. But if you store the knowledge, if you gain the knowledge, that cannot be stolen from others. So that memory alteration cannot be happen in human brain. So unless until if you allow or do some kind of malfunctions or some this thing, right? So that where our new technology has come in a blockchain. So now see, same human body in IoT devices, right? How this communication is passing and taking a decision, where that artificial intelligence is coming to the picture, then where blockchain is. If you know these things, then you take up any one problem and you can solve it. Right? Now with this introduction, what is the IoT? Already you might have seen many textbooks or many lectures and all. These are all network connection of things, right? Connecting to the one. What connecting? Either it may be object, it may be device, it may be vehicle, it may be anything. Even if you go, many people might have smartphones, good cars. Now, if you as soon as you get into the car, you start, then you see the dashboard. Many red symbols will be appeared. After you release the handbrake, automatically red symbol will go. After closing your door, automatically the door symbol will go off. Then after putting your seat belt, now who are doing all these things? All are connected devices, right? All are these IoT devices. All are there in our smart vehicles, right? So this information enables this object to collect and exchange the data. So this has a very good, this over a network without requiring human to human or human to computer interaction. We need not to interact. Automatically our doors will be open, and open means that symbol will come. Even in your mobile phones, how many sensors are there? That is automatically is doing. Now everyone, you are utilizing these services, IoT devices. This IoT term is coined in 1999 by Kevin Aston. He is the pioneer in this, right? Connected each and everything to the internet, right? Relationship with the people to people, people to things, things to things, right? So this where now mission to mission communication, how the mission to mission communications are happening, how these are devices are talking, are exchanging the information, automatic processing everywhere. Now in the automobile industry, if we go assembly, where that car manufacturing assembly, once you fit that body, next one where to go, automatically without human intervention, these IoT devices are sending the information to do that. So how does this IoT works? So here four things. All these things are categorized into three. One is things to collect information and then send. So now who will collect and who will send? Second one is things to receive the information and act on it, and things to do the both. So these all four, we have the collect, communicate, analyze, and act. These are the four things happening in the IoT thing. What to collect? How do we collect? So in many, we are in academicians, many research papers, So what I am reviewing many journal papers. So what we are getting a lot of queries when we also submit papers, and reviewers asking, where do you collect the data? Is it your own data? Or whatever the algorithm you applied is your own? We are collecting the information is very, very important. How do we collect? So when you collect the right data for right kind of problem and right technique, then you'll get a right results. So this collection is a very, very important. So what type of sensors I want to deploy to collect the data? What kind of now wearable sensors also available? What kind of sensing mechanism I required? For example, I want to detect an object. What kind of sensor it is? Whether I want to test a fruit is fruit quality, then what kind of sensors I want to use? I want to check whether water quality, then what kind of sensor I want to use? Whether any metal ions present in the water, what kind of sensors I want to use? Then humidity, temperature, then soil properties, so many gas sensors. I told you electronic nose, electronic nose, their VOC, volatile organic compounds, whether that packed food is correct, packed food is fresh or not. Even many in Zomato, all these things, they are supplying food, whether the food is hot or not, cold, that also we can check by using the sensors. So now your main here is what type of sensor you have to use, what kind of problems. That is very important. Once you select that one, then how do you communicate? To communicate, lot of communication devices are there, right? Now you are using what kind of communication device, or 5G or 6G now, right? Now that communication channels is very important. How to communicate? So now that communication, now everything we are collecting and sending to the cloud. Now what is happening? Even with this information is useful or not useful, now you are storing everything, dumping in the cloud. So that's why now that cloud computing importance are gradually reducing. Now everyone is moving to the edge computing, because of latency, because of the delay. Now in edge level itself, in the device level itself, in there itself, you can reduce the communication cost, you reduce the latency, that speed and all, right? So there you can use that communication transceiver. Then you have to analyze whatever the collected data received to this. Based on the here only that artificial intelligence, machine learning, deep learning, data analytics and all comes. Then you make a decision. What kind of there, how do you control entire this process are based on the actuators. Actuators are nothing but a controllers, right? So this is the entire scenario how these IoT devices works. So these are the four fundamental things, dimensions in IoT. Things, tagging things, feeling things, thinking things, shrinking. What is the tagging? How do you trace something? Because everything has a tag, right? Tag is nothing but now you are giving some name, right? Me is a name. My entire thing we can process. Whether you want to check the fruit, where it has come, which soil it has come, what are how many pesticides they used, all these things can be identified. Now it's okay, madam. Okay. Now audible, madam?
Yes, sir.
Okay, madam.
Yes, it's coming. Yes, sir.
இது இப்போ வருது மேடம். ரீகனெக்ட் ஆயிட்டு இருக்கு மேடம். அதான் வந்து இது நெட் எப்பவுமே வந்து ஃபுல்லா இருக்கும் மேடம். Madam, கேக்குதா madam? Okay. Okay. Sorry, madam. Disconnect ஆயிடுச்சு net. என்ன தெரியல. I will share my screen, madam. Okay. Slides தெரியுதா madam?
Yes, sir. Yes, sir.
Yes. Sorry
Yes,
for
sir.
inconvenience. My net got disconnected. So what happens in the internet in a minute? You see YouTube videos, 1.3 million views are coming. Google search. See, now that is a 2015 slide. Now see the 2020 slide. Same Google. Now 4 million search queries. Okay, YouTube, 4.7 million videos can be used. So WhatsApp, 59 million messages sent. Who will process all these are connected, right? All these devices are connected into the net and doing in the internet. Everything has been connected. That's why that now IPv6 is coming into picture, and so many things now the communication bandwidth, everything they are increasing 3G, 4G, 5G, now 6G they are working on it. Because of all these are connected into our. Even you see our smartphone, how many sensors are there? If you surprise, 36 minimum 30 to 36 sensors are inbuilt in our smartphone. So camera, then accelerometer, temperature, gyroscopy, then all these things. Now wherever you go, then all these things are now visible. Where this IoT devices comes from? So with the wearable technologies, smart appliances, and now healthcare, all these where we are getting the IoT device data from this. So these are early one: watches, eyeglasses, hearing aid, activity tracker, detection. Now how these wearable devices innovation has been. So smart watches, smart Google glasses, right? Then smart hearing aids, Fitbit, activity monitor, like that. So many things, wearable devices are coming to the picture to process and make this our life to be easier with the help of wearable devices. Now we wrote one proposal, but it not sanctioned to DST, how to track or how to identify aggressive behavior in an autism student by using flexible wearable sensors. Because if to autism patients or children, you want to monitor them. If you keep anything to extra, they will throw it. So now that wearable technologies with a shirt or maybe something in a cloth itself, if we have this monitoring mechanism inbuilt in your cloth, right? So their textile, lot of textile industry now using these wearable sensors, right? That now we can use in that and do that. So see that how much investment has been made in a wearable technologies. So in 2013, investor poured how many billions? 458 billions into 49 wearable companies. What are the companies? All well-known companies: Apple, Google, Samsung, all these thing only. Now see this video, how these wearable technologies.
Some health news. Researchers from Korea and the United States have developed an adhesive sensor that, when used in conjunction with wearable technology, could make it much easier to detect cardiovascular diseases before they strike. Quasua has potential predicted by market watchers, and apart from making life more comfortable and fun, it could eventually be a lifesaver. A joint research team from Korea and the United States recently developed a sensor that can be stuck to your skin like a band-aid and could provide early detection of cardiovascular diseases such as heart attacks or strokes. Tens of thousands of microcilia, or hair-like extensions of cell surfaces, have been embedded into a sensor the size of a fingernail. These can then measure fine waves in blood vessels. When integrated with smartwatches or other wearable devices, it'll become easy and efficient to monitor one's health, especially since strokes and heart failure can strike suddenly.
While it was difficult to respond to emergency cardiovascular diseases with existing equipment due to their complexity and high price, the new wearable sensor will be able to help in emergency situations.
Cardiovascular diseases are the leading cause of death in the world. The World Health Organization forecasts more than 23 million people will die of heart attack or strokes by the year 2030. Cost-effective wearable sensors could be the answer for low and middle-income countries, as 80% of CVD-related deaths occur in that group. Konsua, Arirang News.
See how this wearable sensor are usable in a cardiovascular diseases. Now with South Korea and the US, they developed a low-cost wearable sensors to early detection of heart attack. Right? These are very useful in a current trend. These are all the available smart devices in an industry. Electronic pill dispensers. So this has been now extensively used in during COVID times. Electronic pill dispensers, electronic bottles, caps, pouches, then biomonitoring drugs, smart watches, all these things. So these are all very easy, and now everyone is using fitness for well-being, for family, for clinical support, home monitoring. We are using all these wearable sensors. So this has a very good market. If you have anybody have interest to do research on wearable technologies with the help of IoT and artificial intelligence, now you have a lot of market. Only thing you have to take care of all that whether that at the end I will tell you what are all things when you consider for a product development. So you want to make any one product with this wearable technology by integrating your IoT concepts and also artificial intelligence concepts, then this sensing technology for any societal care, any one health, right? Then it would be very good contribution for you. See, another video you can see.
Do you think an orchid will ever be able to tell its story? Do you think a flower one day tell us where it was grown, how it was treated, or how it got here? Do you think it's possible to teach traffic to speak? Do you think a car can call an ambulance faster than a phone? Do you think it's possible for devices to automatically deliver important, often life-saving data to those in charge? Can you imagine an ambulance that gathers critical information before arriving at the hospital? And that a patient could be examined before he even enters the emergency room, saving precious time for the patient and his family. None of this is science fiction. It's all part of a concept that our team has been working on for several years, the Internet of Things. The main challenge for making this dream come true is finding a way to connect many different applications and technologies in one coherent network.
The thing is, they are not connected.
For instance, there are 6 different systems at work in our medical example. We call them silo applications. Before the devices can talk to each other, we need to provide them with a common language. In other words, a set of design rules, protocols, and interoperable technologies.
So how do you build the future? You identify, predict, analyze, and assess the forces of social change. We begin with information. We talk about big data, vast amounts of data flowing from every imaginable source. However, perhaps the most important piece of information can be found within us. With measuring devices, sensors, and genomics, we now have a deeper understanding about who we are. A high percentage of Finns say they like monitoring their own health, looking after themselves, and having a say in their treatment. But there is a significant gap between this understanding and our healthcare systems. If we could combine our personal data with our healthcare services, we would have a new system at hand. A system based on real human needs. It's time to move from nursing to health promotion. Do you ever stop and wonder about all the weird, amazing signals and functions we are made of? With advanced electronic services alongside traditional healthcare, we can give people more and more options when they're in need of treatment. Imagine getting treatment via webcam from the comfort of your own home. Self-care aims to make our lives easier by giving us more opportunities to look after our own health.
See how these devices has been connected and communicating each other and exchanging the information. This is the real example of IoT, right? So now we are also connected. Now, for example, now we have 60 members in the this workshop. All are in different places. Maybe you connected through your laptop, or you maybe connected through your mobile. So all are connected. We are exchanging the information. So this is the power of IoT. Now you are using it, right? Now how this in healthcare? So they are telling that how this, before that they have to develop on a common platform where this can be communicated without sending a malfunctions. There they have to develop some protocols. So one of my PhD scholar working on it. So how to devise a user authentication protocols in IoT devices and also mission to mission communications. So now he is applying in a banking sector, how this can be developed. Already is going to submit a thesis in next month. Okay, so they're devising the protocols, how that communication has made all these things. Then after communication, how they react, how they respond, all these things now collect, communicate, and analyze and act. So these four things, the basic principles of the IoT devices, whether how they are doing, like that you can take up same scenario. Now you represented as a, here, see, same thing. Now body area patient network, then sensing, transmitting, then that whatever the transmitting that things, right? So data and cloud like processing. After that you are using analytics and visualization, doctor. So all this bidirectional. So now the entire this first phase is called a data acquisition, sensing, transmission. Now how do you acquire the data? That's what the first collecting the data, right? Analog to digital conversion. So many devices are there to collect the data. Once you collect the data, how this data can be stored and processed, where you can store it. Previously we are storing in the servers, then cloud. Now we are in edge level itself. We are storing, process enormous data and optimize their size. They're the big data and machine learning come into the pictures. Then you have to visualize whatever the information we got it. So what is the slight difference between analysis and analytics? Analytics are making useful decision. So there different type of analytics are there. Prescriptive analytics and predictive analytics and prescriptive analytics. Descriptive, how to describing about the data. Then predictive analytics. Now predictive maintenance, a very good area where many people are working on it. So there even our healthcare, health monitoring and engine monitoring and any devices health monitoring, all that can be done. Then visualizing. Now, the big data visualization also. Then here this, because it is an healthcare, that's why I given this slide. If when a common for any system, if you take any system, then you have to sense data acquisition, sensing, transmission, then storage and the process, then analytic and visualize and make a decision. These are the main core. For example, see now care bots are coming into picture and making many care bots. They are developing in even Japan. For elderly people, they have a lot of care bots. So a link is given. If you have time, you can go through that. So what is the future trends now in IoT? So see how the years, number of connected devices, 1990, 0.3, 2009, 13, 9 billion. Then 2025, they're expecting 1 trillion, more than that. So 63 devices connected every second. So how do we process? Right? So some technology analysts predict that by year 2020, we have 28 billion things to connected to the internet. But 2025, 1 trillion. So see the growth, how this been connected. Everything is connected in the internet. If internet, see, my net is disconnected, I'm not able to speak. Now everything we are dependent on the net only. Okay. So here the future trends in IoT in India and how Indian IoT market as there, right? That is by NASCOM source. So the Indian IoT ecosystem rapidly expanding owing to demand for both industrial and consumer IoT applications. See the current IoT market size in India comprises India. What is the current size? This much. Now that they are expanding, expected India IoT market size by 2020. How many organizations? 120 IoT organizations. Okay, startups. Now many startups, if you search in Google, IoT for agriculture, IoT for medical, IoT for smart transportation, IoT for smart houses, all that things, right? See, investment made startup offering innovative IoT solutions since 2014. Many government of India taking initiatives to promote these IoT devices, promote the technology innovative, emerging technology innovations. That and all. Now see, they are newly have a lot of policies make in India, right? So they're giving a lot of opportunities for us to start within a startup companies. Okay, today I was signing with after this meeting, 5 o'clock, I'm signing with one startup company. There, what is the farm sensing by using farm sensors? How to detect heavy metals in water with the help of artificial intelligence also we are introducing. One startup company. Right? So there, see, like a lot of opportunities are there. Investment, their government is ready to give. And you have to see to it where my problem fit in. What kind of problem I can able to solve it. See, go to these initiatives, Government of India initiatives. Go to that DST.government, Internet of Things, IoT Research Initiatives. There, so many calls are coming. Okay, you can approach, you can apply. You be in one or two members, you make a group, the expertise in the domain, IoT people, then an artificial intelligence person. 3 or 4 people. You can do, definitely go to this website https://dst.go.in, Internet of Things IoT Research Initiatives. So a lot of initiative has taken place into that. So if you see this diagram, so now utilities, then agriculture, how much, retail, healthcare, automotive, transport and logistic and manufacturing. So now in our institute, we have one center of excellence in the manufacturing. Siemens company has invested 150 crores. 150 crores. Now we have a BHL here near to our institute. We have a tie-up with the BHL. Now last week we had an industry and institute interaction meet one day. So we visited BHL and we are there. They're giving their problems and here how our technology can be useful to solve their own problems. So that way, that communication, right? So their market, IoT markets in India, how they are and different fields, that you have to take into consideration, right? These are the challenges. Now see this.
The Internet of Things, or IoT, is influencing our lifestyle from the way we react to the way we behave. From air conditioners that you can control with your smartphone, to smart cars providing the shortest route, or your smartwatch which is tracking your daily activities. IoT is a giant network of connected devices. These devices gather and share data about how they're used and the environment in which they are operated. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, vehicles, barcode sensors, traffic lights, and almost everything that you come across in day-to-day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data, and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data, and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analysis is performed on the data, and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiency. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product was distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many more. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature. This data is analyzed continuously, allowing the customer care to contact you for the repair work in time. This is just one of the million scenarios. We have smart appliances, smart cars, smart homes, smart cities, where IoT is redefining our lifestyle and transforming the way we interact with technologies. The future of IoT industry is huge.
See how this IoT, you can, after seeing this video, you can get a clear idea how that IoT devices are helping us and solving our own problems. That AC manufacturing units, where it is the supply chain management, entirely they're tracking, all they're maintaining with help of IoT only. So last year I attended one workshop in IIT Bombay, where there are now virtual sensors, right? That we called as soft sensors. So one person from a company called GE, General Electrical, he came and presented one talk where the transformers, different transformers are he presented that predictive maintenance. How do you maintain the transformers with the help of soft sensors? That is a virtual sensors. So now so many transformers are placed in a different locations. So how do we gather that information? How much old it is? When to replace? There will be some oil in the two tanks. So sometimes transformer will burst. How it has been burst? Because of lack of oil, or maybe some due to some condition not properly maintained. So there he has want to deploy some infrared cameras and do, but it is costly. Then they adopted virtual sensors and soft sensors and able to predict health of the transformers. Now they are deploying in throughout our India, all the GL. Like that, you want to think any one applications where you can apply these concepts. How to take as in a product level, not only the paper publications, But now you have to think beyond the paper, and you have to develop some product or prototype or technology transformation. That where you need. So this is the entire scenario, conceptual framework for IoT devices. So now different applications, what in a smart home, smart parking system, air pollution monitoring, all these are all the where the data is fusioning, how they are combining different data. That is a fusion, data fusion, semantic approaches, tensor decomposition, physical social data correlation, social data as a context. Like that, how the data fusion is happening. Where the data, see, these are the sources, different physical, mobile sensing, fixed sensors, right? Social network, all these are sources for the data. Okay, sources for the big data, right? All these are the devices, IoT devices. So these devices generate the data. Then you have to do this data pre-processing. Very, very important. Event detection, classification, clustering, decision, all these things. How this data pre-processing, how these analytics can be made with the help of artificial intelligence, with the help of machine learning only. So this machine learning is a sub-branch of artificial intelligence. So this artificial intelligence are being divided into three branches. One is, or we can say that three approaches for artificial intelligence. First, this artificial intelligence was there in the 1950s. Now, why we are talking, that I also will tell. So first, initially when they developed, they had used expert-based systems. There now we have to devise rules and regulations for each and everything. In our real life or in a real world, all our problems are not a static in man. All are in dynamic nature. So every time you have to devise the rules. For example, previously we have not heard about this COVID situation, pandemic situation, all these things. Now entire healthcare system has been changed. Human life has been changed. Our classes, our classroom teaching has been changed. So same seminar might have conducted our workshop, I would have come to the Coimbatore CIT, then I have to talk. But now virtual. So how the scenario has been changed, how we are adopting that system. So whereas that expert system are not able to adopt the dynamism. So there we have to devise a lot of rules and regulations. There a lot of limitations are there. Then they thought of why not other approaches. Then they went to intelligent based approach. There the computational intelligence, swarm intelligence are come into picture. Everywhere that computational intelligence techniques, particle swarm optimization, genetic algorithm, anti-colony optimization, firefly algorithm, fuzzy systems, all artificial neural network, all are called the intelligent systems or bio-inspired algorithms, nature-inspired algorithms. So whatever that ant has the intelligent, bird has that intelligent, that they mimic and they adapted. Then third one is a learning approach. So artificial intelligence, first expert-based approach, then intelligent-based approach. Third one is a learning-based approach. Here the learning, what are the type of learning? How mission, see all the devices are now missions only. All the devices. How this your app or your developed device or a mission will learn it. How we are learning. How our child will learn. Like that, mission making mission to be intelligent. Or mission learning is the one we are doing the same process and again without being explicitly programmed. So this has the ability to autonomously work and integrating the knowledge. Then only, see, now ETI, when you go some cab and all, it will give the ETA, expected time of arrival when you book the cab. How this GPS, your device knows that? Who taught them? Then if you put the route in the GPS, then you change the route. Automatically it will redirect and calculate the distance and tell it. So how this has been learning? If you visit some hotels or shopping malls, then your mobile will tell you how was your experience with that hotel. Now give the feedback. How these things are happening with the help of machine learning only. This machine learning has broadly divided into three types. One is supervised, another is, why I'm telling here is a machine learning. It is not enough if you have only IoT devices. It is not enough you only sense that one, collect the data and transmitting. Next one is how do you process the data. So first, for sensing, I told so many sensors are there, so many types of sensors. Okay. Then communication, we have a lot of communication, 5G, 6G communication models. How we are transmitting with the Zigbee or Bluetooth or Wi-Fi, or whatever the mode you are using to transmit. Then you have to analyze your data, IoT data. For analyzing, for processing, you need these techniques, AI techniques. Okay, supervised is, now you know the target variables, and unsupervised you don't know, right? Here two important problems, clustering and classification. Both are problems, not of the techniques. Clustering is the one problem, classification is the another problem, right? Like in a computer science, we used to say sorting and searching are the problems. Like that here also clustering and classification. So now when do you say that good cluster? When you have the inter-cluster distance should be minimum, intra-cluster distance should be maximum. When you say it's a good classifier, when you have the classification error is minimum. We are able to classify two distinct classes. Like that we have use the classification and clustering, supervised and unsupervised. Third one is a reinforcement. It is work based on the reward and penalty. For example, that also we are using every day. When you pay the Google Pay, now you will get some reward points. Right? First transaction, no one will get a better luck first next time. You will get either 2 rupees, 5 rupees, 10 rupees as a reward points. After 2-3 transactions, you will get a message better luck for next time. That means the people are making you to adopt their system. Okay, even SBI cards, SBI reward points. Now any online purchase, reward points you are getting. So this entire thing work based on the reinforcement learning. Entire thing, see, reinforcement learning. Because a lot of machine learning techniques are there that I am not discussing. Here reinforcement. See, observe, select an action policy using any policy. Here agent is there, environment. Here two things, fire and water. So this agent, this device. So if you touch here, you'll get a penalty. If you touch here, you'll get a reward. So now if you see action, third one is action, then get a reward or penalty. So now minus 50 is a penalty. Mainly used in a gaming theory, and many deep reinforcement learning algorithms are also there. When you know the target variables, that means target variables, label data you know, then you go for supervised learning. If you don't know the target variables, go for the unsupervised learning. You don't know the environment itself, then you can go for reinforcement learning. In this reinforcement learning, Q learning is a one good concept. Then SARSA is another learning, right? So there, deep reinforcement learning has been extensively used to train the robots, to control the environment. Even we wrote one proposal for ISRO when liquid rocket engine we are moving from a steady state to running state. In between, transit state will be there. So there, how we can apply reinforcement learning to study that transit state signals. So for that, we wrote on a ISRO project also. It is under consideration. So then it will update your learning step. If it is a penalty, then it is bad. Avoid next time. So whom the reward points will give? More number of times you purchase, then you will get a more rewards. Right? So this will be iterated until optimal policy is formed. These are the 6 steps we used in a reinforcement learning. Right? Now, these are the machine learning. So then people are moving to deep learning. Before going to machine learning, there are n number of classifiers. There we can use the ensembled classifiers also. So there we can combine 1 or 2 classifiers, then we call it as an ensembled classifier. Random boost, random forest, ADA boost, bagging, stacking, all these are ensembled classifiers. Now, what is the main difference between machine learning and deep learning? So, in machine learning only uses one layer approach, right? So, one hidden layer. Then deeper means simple to understand. When you are a teacher, you taught the class, student will understand, will write exam. So that is simple. Okay, then you are giving input, they are processing it and giving as output as an exam. Then you grade them and all. Then means you know all the students who study well, all that things. That is simple machine learning. You want deep learning means now the same one or two students coming to you for a project work. There you will ask, now what subject you studied, what is your expertise. Then you are going deeper into know. That means you are extracting more number of features. So in machine learning, the feature extraction is a separate step. But whereas in deep learning, the feature extraction and classification combined. So the model itself, deep learning model itself will extract all that information features. So why it has been more popular? Because of this GPU, because of the massive parallelism, because of NVIDIA. Okay, that's why everyone is now moving to deep learning. So without GPU, with the GPU. So how much time it's? Why we are going for GPU? Every set of weights can be stored as a matrix. GPU made to do common parallel problems faster. All similar calculation done at the same time. This extremely boosts the performance in parallel computation. Because of this GPU, now everyone is NVIDIA, they have Jackson boards, all these things, right? So this where this machine learning, deep learning comes. See this extraction. So these are all the good models are there in a deep learning. One is a deep neural network and CNN and RNN. So when to use these models is very important. When we have the data set to forecast or classify, then you go for deep CNN. Then feature extraction and classification of images, then go for CNN. See here, feature extraction and classify. When you have sequence of events or language models or time series models, go for it. Here, one more important technique is transfer learning. What is the transfer learning? Is nothing but a pre-trained models. In CNN, convolution neural network, there are n number of pre-trained models that are Google Net, AlexNet, ResNet, VGG60Net, all these pre-trained models. What do you mean by these pre-trained models or transfer learning models? So you need not to start from the scratch. It is enough if you change the upper layers on a hyperparameters, then your work will be done. Already these weights are being calculated and has been proven for many good algorithms. So that you can adapt to your problem, you model it, you change batch size or learning rate or whatever that epochs, number of epochs, all that things if you change according to your problem, then it will work. Only your softmax layer you have to change. So this is a very good, now many people, many researchers, you want to get a good publications. Now you utilize this opportunity to implement your problem through the pre-trained models or transfer learning models, and you compare, then your paper will be accepted very easily. Because now you are going to machine learning, SVM you use, naive Bayes you use, classifiers, then no use, right? Now the well-established models has come. What is the recent models? ResNet or VGG 16, 19 models has come. Then YOLO models are there, right? All this can be used. In RNN, LSTM models are there. GAN network, right? Auto encoders. All these are the new techniques in deep learning that you can use in, right? So far, what is the introduction of IoT? IoT, how do you process by using artificial intelligence then these are the applications. Next time, applications and challenges I will talk. Okay, so so many applications are there, right? So smart logistics, smart parking, smart healthcare, smart wearables, transportation. So 10 cool IoT application around the world. So now wherever you are interested, if you take any one, if you take a smart agriculture, plenty of problems are available. Take a small retail, plenty of problems are there. You take one problem, one area, then you go deeper into that. Smart cities. Now I will take on a smart home one example here. Now smart transportation also. See this next slide. Now how this smart self-driving cars.
We spend so much of our lives driving from place to place. I'm just gonna stop. Yes! Save us a seat. Shouldn't it be easier and safer to get where we want to go? Since 2009, our team at Google has been developing fully self-driving technology and testing it on real city streets every single day. Until, after more than 1 million miles, we were ready to take a big step forward. In 2015, we completed the world's first truly driverless ride on public roads. Just a person in a car, no steering wheel, no pedals, navigating everyday traffic.
Well, I've never been in Austin, Texas. Now I'm driving in Austin, Texas. It's a profound experience for me to be alone in the car. A very important segment of my life was cut away when my vision failed. And a self-driving car would give me a huge part of my life back.
This is just the beginning. We're looking ahead to a new way, a better way for everyone. Say hello to Waymo.
So this smart transportation, we have plenty of problems. How these devices are communicating, how these devices are classifying the pedestal or object, how it is identifying the signal, traffic signal, roads and the climate, all these arrow marks, everything, right? How these are communicating each other and making a decisions, right? Without driver, right? So it is a self-driving cars. So how this will be possible? Because of this IoT, because of this technology, because of this communication, because of this machine learning, right? So all are inbuilt. So now you see, when you want to start in a very good problem, first what you have to do, you have to take a recent survey. What are the future challenges of this technology? Now, then in the survey papers, latest survey papers, they mentioned challenging problems. That you take up and apply your own method and get a results. Okay, like that, so many things in a smart health. So already this has been explained, how this Fitbit and all that, everyday well-being, because everyone is fond of your healthcare now, right? So how this healthcare system has been now with help of IoT are doing, how the decision support is giving, anthropology, evidence, inference from data mining. Huge data has been, from all these sources, data is coming, and this data is going to there. Then they are inferring and making a decisions and sending for training, coaching, or social network, health informatics. Then that person will get it. So these IoT-enabled clinical trial solutions evaluate a specific outcomes. Wearable devices to monitor pulse, heart rate, walking, biking, all health data. So there, now sensor-enabled mobile devices to remotely monitor patients' health and chronic illness. So mobile-based, because everyone has a smartphones. Now smartphone-based devices you can develop, right? So in a smart transportation and logistics, how these sensors can be used. Sensors to detect empty mailboxes. Temperature bands, sensors to monitor and check the quality of the food being delivered. What kind of food you are being delivered. So these temperature bands are able to check the quality of food being delivered. tracking the devices to keep the check on the temperature, condition, package, location, etc. I read one paper through electronic nose, e-nose, that gas sensors. We are able to store grains. How do that stored grains, any insects or fall in many stores, because now you have ration shops, right? In many places they are storing, dumping. Now even after farmer, he will also keep in warehouses. There we can use these things, right? E-nose to get whether that grains are being spoiled or not. In a home, we have that food and any spoil, then automatically the smell will come. That same smell through e-nose, electronic nose, how our nose are smelling, that things. Sensor can keep check the conditions of the consumable supplied. So in a smart retailer, smart watches, see smart mirror in a Google. So use of RFID, heart rate polio shots, all these things. Now many textiles, if you go to the many textile industry in fashion design, now IoT, artificial intelligence are being used. Many places, right? So now coming to that last topic, artificial intelligence and IoT in agriculture, smart agriculture. See, lot of problems are available. Now this is a one device, how that IoT cloud, then we are giving to the mobile based. Future of smart agriculture with a modular IoT game. So this vehicle monitoring, climate monitoring, livestock monitoring, soil moisture monitoring, plant health monitoring, pest control, water supply control, crop monitoring app, inventory management app, livestock tracking app. All these are on individual problems. It has now we are working, and my team is working on a pest control, insect pest monitoring. Right? Recently, I wrote one proposal for emerging technologies initiatives for Government of India. Throughout India, they selected 12 projects. So one of the our project also selected on that emerging technologies. There I wrote on a smart pest detection monitoring system using artificial intelligence, where different field crops and vegetable crops are there. Different types of insects will fall in. So how to detect, early detection to save that crop, right? For that we developed already we developed AI models. One of my PhD scholar, she is a woman scientist. She is going to she already submitted the thesis last week, and she worked on how we can make this insect pest classification and detection and recognition by using artificial intelligence. Now we want to deploy that model in a IoT platform. That means edge computing. Now same concept we extended, and we have a tie-up with the Sony company. So there they have a presence board that I will take you in a few slides later. There now we have to work on their presence board. So we have to deploy an edge presence board, edge AI presence board. They have one board. So there we have to embed our AI developed models, and we have to install these things in a different crop field, and we have to monitor whether this system are able to really helpful for the farmers, and they are able to send the messages to the farmers in a early detection in their own language. That where we are also doing. So insect and pest monitoring and schedule, release the pesticides. What type of pesticides are to release? So these IoT devices can. Geofencing livestock, farm equipment sensors, irrigation scheduling, pump control, all. So and a sensor to monitor humidity, temperature, all these things. See this. This is the one Microsoft and ICRISAT in Hyderabad. They developed on a mobile app and IoT based for smart agriculture. Showing up at what time they have to show. So they'll consider all the temperature, humidity, soil quality, what to show and all. See this video.
a rain-fed farmer preparing for agriculture is a fragile soil-water equation, where timeliness and precision decide on the returns. Even a week's delay in rains can spoil the harvest. Each year, farmers in Andhra Pradesh bring all their traditional wisdom into play to anticipate the best time for sowing their crops. But with climate change and a rainfall deficit, the stakes for getting the timing right are rising. For them, the difference between a profitable year and a failed harvest is information on the optimal time to plant their fields.
Sowing date as such is very critical to ensure that they get a good crop stand, and if it fails, then lot of costs are involved in the seeds as well as the fertilizer applications. With this background, ICRISAT and Microsoft together decided to develop a computer-based sowing date application.
The sowing date application uses powerful cloud-based predictive analytics to advise farmers on the best time to sow their crops, depending on weather conditions, soil, and other indications. It uses Microsoft Cortana Intelligence Suite, including machine learning and Power BI. Users have access to an instant overview of factors that determine a healthy crop. The tool helps with insights around soil health, fertilizer recommendations, and 7 days weather forecast.
The experiment we undertook in Andhra Pradesh is already showing positive results, and the farmers who are using our prediction services are enjoying high yields.
ICRISAT టైప్ తో చేసుకుని పార్ట్నర్ గా జాయిన్ కావడం జరిగింది. అది జాయిన్ అయిన తర్వాత ప్రతి గ్రామంలో దాదాపులో రైతులతో సమావేశం కావడము, చిన్న చిన్న గ్రూప్స్ లో మీటింగ్స్ పెట్టడము. ఇప్పుడు 175 మందికి రైతులతో మనం ఈ సంవత్సరం మొదలు కావడం జరిగింది.
జూన్ లో తొలకరి వర్షాలు పడితేనే విత్తనానికి మొదలైపోయేవాళ్ళం. కానీ సార్ వాళ్ళు ఒక కొత్త ఫీచర్ పెట్టి మాకు SMS పంపిస్తాము, ఆ SMS వచ్చిన తర్వాతనే మీరు మొదలు పెట్టుకోండి అని చెప్పిన తర్వాత మేము ఆ SMS కోసం వెయిట్ చేసి వాళ్ళు జూన్ 20 తర్వాత నుంచి విత్తుకోండి బాగుంటుంది అని చెప్తే, మామూలుగా ప్రతిసారి జరిగేలా కాకుండా కొద్దిగా వాళ్ళు చెప్పిన టైం నుంచి అప్పుడు విత్తుకున్నాం. ఆ విత్తుకోవడంతో మేము దాదాపు ఒక వారం 10 రోజులు వెనకబడినట్లు అనిపించింది. కానీ దీనికి తగినంత తేమ శాతం భూమిలో ఉండిపోయి మొలక శాతం పెరిగింది.
This particular approach of taking the advisory based on the scientific information have benefited in harvesting 30 to 40% increased crop yields during the last rainy season.
ఇదే కాకుండా వచ్చే సంవత్సరంలో 2000 మంది రైతులకు ఈ SMS ల ద్వారా,
all of which means farmers have some help from modern technology to add to their traditional wisdom. This translates into healthier crops, increased incomes, and happy families across rural Andhra Pradesh.
Same ICRISAT, they developed on a crop doctor, Plantex X, right? They're also showing health monitoring, any disease detection, all these things with help of IoT they're doing. So this kind of why I'm showing these videos are real time and the existing one which we are doing in our India, right? So how this technology has been transformed the lives of people. So in traditional agriculture, we have a lot of problems: manpower, human, right, machinery, large scale production capacity is low, lack of unified standards and procedures. Now see that IoT agriculture using sensor network can quickly obtain farmland environmental data, real time and accurate. Here the farmland information is limited mainly through sense, the presence in the time consuming, but not in the real time. But whereas in IoT based agriculture, we can get the farmland environmental data in real time and accurate. The sensor network to collect the information transmitted to the background processing center. After analysis, we can precise large scale automation, management and control. in a smart homes, sorry, that what you call in a greenhouses. Now many places now there hydroponics, now it's coming into that. So a lot of technologies are coming into the IoT. So that precision farming, where we can use the soil map and crop conditions and soil moisture level, GPS tracking, then where data analytics we can do, plant and soil sensors, now understanding the what conditions we have to, we can see seeds can be given, and pesticides, all these are different levels of precision farming, right? So the data collection, data interpretation, and how we can apply in a different places. So there IoT is playing very important role. How this agricultural drones also helping in many places, and for crop monitoring, animal monitoring, and building equipment monitoring, then mapping, spreading, all the fields they're doing, right? So these are the some of the applications. Now, recently in Gujarat and Andhra Pradesh and Telangana, many places, drones to bring down the locust swarms. So the locust as a very big problem in Gujarat. Then they have used the drones to do that. Okay, I have that video also, I will show. And this is our model. We train. We have the crop insights. Now we have taken a different data sets from the NBI. Where this IoT is coming here in your problem. So our problem, how that sensing, that now in the field, if you keep sensors, so that how do we IoT technologies coming to it. This is our proposed CNN model and is able to classify all that things, right? So in a greenhouse environment, so see this one, all IoT sensors only. Sensors, pH sensors and ppm sensors and temperature, humidity, all light, and all this will sense and transmit to the base station, then it's stored in the cloud. So then the greenhouse monitoring, alert notification through internet, and critical equipment control. How they are controlling, what they are controlling in a greenhouse applications, moisturize, temperature, water, light, all these conditions, greenhouse sensors monitor to control, communicate, and now what do you call, some gases that can be connected, and this information a person can be sent to the smartphone. Through smartphone, he can able to monitor and control his entire greenhouses. So that's where this IoT plays in. So purpose of specific sensors are connected to wireless modems. They send a periodical environmental data to the user over the internet. He analyzes the data remotely, adjusts the plant environment. Whether this has the moisture sensors, temperature. Now you want to give the water. Now that it look like a rainy, then no need to switch on the tap, right? To give the water. So we'll wait for that. After that you can give. So like that, the devices themselves will communicate and give. This is really using in a industry now. So this you see the livestock. What is the livestock of their monitoring? How they are doing livestock monitoring? You see here. This what I told in a Sony company has the presence edge AI board like Arduino and Jackson Nano board and like that. Now this is that board. This board has the three things. One is what do you call a camera module, main model, and extension model. Okay, so they're what they're doing. So they're deploying some monitoring mechanism algorithm for cattle behavior AI analysis. Tokyo University, Tokyo Technology, they developed. And this edge, that means this device, IoT device, are tagged into the each cattle, right? See, each one has the tag, right? Each one has the tag. So this, what their cattle behavior data, water intake, feeding, prone, standing or walking, how much water it is take, whether it is healthy or not, or what is that environmental data, temperature, humidity, light intensity, wind velocity, all that things they are taking, and they are monitoring all the cattle's, right? Cattle behavior. So this is a very good application. So this information has been transformed to the cloud. Then from that cloud, they're having a reports in a smartphones. So there now you can use this presence board are cheaply available. Whatever we develop the model should be cost effective. So that we can have that livestock monitoring. So they're using this one. Next, see, smart irrigation, impact of IoT on irrigation. Olden days, we have a lot, how much water is going. Why now wirelessly connected sensor control the water flow in fields. How this water flow, drip irrigation, all that things are there now. Now see how they are controlling. So this saves the wastage water, gets activated only when the soil gets dry. These sensors, no, only activated soil gets dry. If it is as, it will not activate. So who is it can be done? Now smart water meters, smart leakages in that. Even in a industry, we wrote one proposal, and it is not considered, but we wrote a proposal that is not, we have to somehow we have to work on it. Methane gas emission can be detected by using the different IoT and artificial intelligence. Okay, methane gas emission, because a lot of issues are coming in methane gas emissions. So like that you can do that. Smart irrigation projects, right? Now gas pipe leakages can be detected by using your smart IoT devices. So there now smart water meters, how much water, even in Bangalore and all, they everyone everywhere has that smart water meter. So how much water they are consuming, based on that billing is coming, right? Then you can monitor it. So that your IoT devices can be more helpful for the farmers for a smart irrigation. And when you want to do this thing, what you have to keep in mind is prerequisite for designing IoT models for Indian farmers. So you want to devise any model or any device, these are all the challenges you want to take. First challenge is your model should be robust. The robust, it should be diversity, the complexity, and the spatio-temporal variability and uncertainty of product and services. So whatever the model you are developing, this model should have the features of diversity and spatio-temporal variability should be taken care, and whatever the uncertainties can be happen. For lastly I said locust and some kind of insects fall in, how do we control all that things, temperature suddenly changes, all these things can be considered. Okay, so then scalable, because in the foreign countries scenario, our farmlands are in a very have lot of overheads. That means extra burden should not be there. So that way your product you have to develop. That way you have to devise your IoT modules. Then affordability is very, very important. Just because farmers are facing a lot of problems for profit and all, right? So there now you cannot say my system is excellent. You can be utilized in your farm, but it is this much cost. Who will buy that? So affordability is very, very important. So that's why they said key to sustainable benefits. Standardization platforms, tools, products, services can bring the cost down with the increased volumes. Then only you can use. Then last one is sustainability. Not only the robust, scalable, affordable, and it should be sustainable. The issues of sustainability is vital because of intense economic pressure. And you cannot say my model only work for this. After that may not. After 5 years, what is the sustainability of your product? That is very important. So when you designing or planning to devise IoT things for Indian farm, these things you should consider. Okay. Now see, up to this, I would discuss the smart agriculture. Now smart home. I will take the video, then I will discuss how it will work. Then we'll. Madam?
Yes, sir.
Madam, my laptop is disconnected, madam. I didn't get a connection after that.
Okay, sir.
Okay, madam. I will conclude and whatever the topics I discussed in orally, madam. Okay.
Yes, sir.
2
Yes,
minutes,
sir.
5 minutes, madam. So
Yes,
far
sir.
we discussed about the 2 to 3 minutes. I will conclude it, madam. Okay, madam. Is it
Okay, sir.
So far, now we have seen different how IoT can be used in different applications, either in a smart home and smart agriculture and transportation and healthcare and all. So while you're doing it, you have to take care of how that devices, whatever the things you are taking, that will be affordable and scalable, and it will be whatever the sustainable. That way, lot of applications are there. Now you take one domain, either agriculture domain, either healthcare domain, or transportation. According to that, you choose your own problem and apply this IoT technology and machine learning and artificial intelligence. Lot of next generation sensings also in communication also, because your ECE department in communication protocols you can develop. So many things you can do with the help of this one. Okay. So with this, now I will conclude. Now because sorry for the inconvenience, my laptop not able to connect with the internet. So through mobile only I am now speaking. Okay. Thanks for the opportunity. If you have any doubts and queries, I will clarify. Thank you, madam. You can ask any doubts and queries. And I'll. If you have any queries, thanks for the participation. And you have any queries, please feel to ask. Thank you, sir. Dharmalingam, sir. Thank you.
Thank you very much, sir. It was really a very interesting session, sir.
Madam. Because of
Sir,
network,
Sir, that is not a very big issue, sir. We have learned very lot many topics from you, sir, and we really it was a very interesting session, sir. 2 hours we didn't think like it has gone in a blink of an eye, sir. We had the more insight on the topics you have taught, sir. Thank you very much for sharing your knowledge, your experience for with us, sir. It was really a very great session, sir. Thank you.
Thank you, madam. Thank you, madam. I'll share the PPT, madam. You can circulate with among the participants.
Thank you so much, sir.
Thank you. Thank you all. Thanks for the organizer to invite me. Thank you. Thank you. Madam, shall I leave, madam?
Yes, sir. Thank you, sir.
Thank you, madam. Thank you, madam.